All right, so we are on page 2. All right, we're going to get pretty far today. We already did page 2. Oh, well, I'm sorry. We decided what we're doing on page 2. And we already started on number 2. We found angle Q and angle R. We need to find the third side of a right triangle. So what do you use to do that? How do you find the third side of a right triangle?
Pythagorean theorem.
Yep. So you're going to have the a squared plus b squared equals c squared. All right, so 5 squared plus 12 squared equals c squared, because this is your c. It's across from your right angle. Now, we're going to make it easy on ourselves, and we're just going to put a little radical sign here and here. So square root of c squared is c. That's easy. All right. And then this part here, this square root of 5 squared plus 12 squared, we're going to put that in our calculator. And we're going to come up with a number. Should be a whole number. What do you get? 13. You do get 13. Okay, so the measure of PR is 13. I do also tell you all the time, try and learn some triples. 3, 4, 5 is the smallest Pythagorean triple in the universe. If you double it, you get 6, 8, 10. If you triple 3, 4, 5, you get 9, 12, and 15. Well, this is a 5, 12, 13. That is also a triple. 5, 12, 13. So if you memorize triples, you don't have to do Pythagorean theorem. But if you can't remember them, it's okay. Just know that you're going to have to do the math. All right, so number 4. Now number 4, if I look here, number 4, it says solve for x, and x is a length of a chord that's on the inside. So we're talking about this one right here. Chord, chord, and so it's piece times piece equals piece times piece. So I'm going to kind of color code. This piece here gets multiplied by that piece there. All right, so 6 times x. And then we have this piece over here times that piece over there. So we get 9 times 8. All right, so we have 6x. 6x is equal to 72. So then we divide here, and what do we get? 72 divided by 6.
Well,
Yep. We do get 12. Okay, if you want to check your work, you can always just plug 12 in right here and make sure that this side equals that side. All right, now number 5, we have a secant here and a secant here. Now, something I thought of, secant starts with an S, right? Okay. An S has 2 little loop-de-loo kind of things and 2 little points on the end, right? Guess how many times it hits your circle? Each secant hits the circle how many times? 2. See? 2 dots? 2 dots. Isn't that brilliant? I just came up with that. Here's your tangent. A tangent is an intersection, one intersection. Guess how many times a tangent touches your circle? Once. Genius, I know. Hold your applause. Okay. All right, so this is 2 secants, which is right here. And it is the whole thing times the outer number equals the whole thing times the outer number. All right, so on this side here, you have a 5 and an x, so the entire thing is 5 plus x. It is a thing, a whole unit, 5 plus x. The outer number is a 5. On this side, we have 6 and 6, which makes 12. And then my outer number is a 6. True? Yes, no good?
Yes.
Okay. So, 5 times the 5 plus x, and that equals 12 times 6. Now we're to distributive property. 5 times 5 is 25. 5 times x is 5x. And 12 times 6 is 72. Hey, I know that from the previous question. I didn't even need to type it in. Then we have to subtract 25. So we get 5x, and that equals 47. And now we're going to divide by 5. So we get x is, tell me that answer. 9.4. Very nice. Okay. All right. So, and by the way, just a little side note. If you're someone sitting here going, I still really don't get why are we distributing? Because if I have 5 sets of 5 plus x, it's a lot easier to multiply than it is to go like this. 5 plus x, and write it down 5 times, which you can do, and then add that up. Okay, so how many x's are here in this column? 5 x's. And then if I have 5 plus 5 plus 5 plus 5 plus 5, that's a 25. It's a lot easier just to multiply. That's really what distributive property is doing for you. It's a shortcut. Okay? Multiplication is nothing more than repeated addition. All right, number 7. Okay, so this one is a secant and a tangent. So that's this one here. And that is whole times whole, which is your tangent side, and whole times outer, which is your secant side. So the entire secant is a 20. 12 plus 8 is 20. The outer number is 8. Then on my tangent, this is my tangent, the entire outside is a y. So y times y equals 20 times 8. Y times y is y squared. 20 times 8 is 160. And then we're going to take the square root of both sides. Okay, we want y by itself, so I got to take the square root. So I get y equals, what's the square root of 160? Huh? 4 square root of 10. Okay? All right. Oh, before you leave today, remind me to tell you something about simplifying radicals in the delta math so that you work it easier. Okay? All right, so now we're to this. Now we're dealing with angles. This is x degrees, and this vertex is outside. We have an arc right here that is 140. Well, a circle is 360 all the way around. So if that side over there is 140, what's this side? What's this side? 220. Okay? So I have this arc, and I have this arc, and I have x degrees. Okay, so we're talking about angles, so I'm going to be right here, and it says that the angle is half of the big arc minus the little arc. Remember I wrote all this down yesterday for you? Okay, so my angle is half, and we're going to put the big arc first, minus the little arc, and we're going to take half of whatever that is. So half of, so 220 minus 140. What do you get? Okay? So now I want you to think in your mind, what's half of 80? 40. So that angle out here is 40 degrees. Okay? And now we're over here. Now I see an angle. We have a ray, and the vertex is on the edge of the circle. So I want to know how big this angle is. And here's the arc that is in between the arms of that angle, okay? And that arc is 200 degrees. Well, what kind of angle is that? Central, inscribed, inside, outside, what kind of angle is that? It's inscribed. See it? Look, it's right here. It looks just like what's on our paper. And it says that the angle is half of the arc. So my angle is half of the 200. So how much is that angle? It's half of 200. Okay? Okay, so this is all the ones on page 2 that you asked for. All right, now let's go to page 3, and I want you to take just a moment. Again, these should have been numbered 1 through 12. I want you to tell me which ones you want me to do. You pick. Don't work them. Just let me know which ones you want me to work. Tell me what to do. Okay, so we'll do number 10. What else? Okay, so we have a triangle inside of a circle. It says the measure of arc AD is 100. Well, arc AD is down here. Well, that's 100. And it says find the measure of CAD. That's this angle right here. Nope. CAD. Just kidding. Not that one. Starting at C, going to A, going to D. That one there. Okay. Now this one is actually a really cool question. First of all, what is the measure of angle C right here, this yellow one? How much is that? If this is, this is 100 because it's a central angle and it matches the arc. Now I'm going to draw this out here so that you can see it better. This is A, and this is D, and this is C, and we know that C is 100 because it matches the arc, and we're looking for CAD, that angle right there. Now the other thing to keep in mind is that C to D, this is a radius, and that's a radius, and that's a radius. Do you guys agree with that? Okay. Well, if this is a radius and this is a radius, what do you know about all radii of the circle? They're congruent. Okay? So, if this side is congruent to this side, what kind of triangle do you have? And if you have an isosceles triangle, what do you know about these base angles down here? They're the same. They're congruent. So, do you know what these are? No, we can give them an X, right? And we have one x over here and one x over there. So we have two x's. And then we have the 100. And then all three of these angles have to add up to what?
180.
180. So now I can just solve for x and I will get the measure of the angle that I need. So the first thing I do is I subtract 100 and I get 2x is equal to 80. Well, if 2x's equal 80, what's 1x?
40.
It's 40. So how much is the measure of that angle?
40.
Okay, so that is angle CAD. That's a lot of stuff in that one tiny little question. Right? You had to understand a lot of geometric concepts in that one question, and not all of them were taught in Try 3. Okay? The only thing in Try 3 is the fact that this angle here and this measure here are the same. That's the only thing that's from Try 3. Everything else is prior. Isn't that beautiful? It is. Okay, number 4. And we have a triangle that is equilateral, which means this side and this side and this side are all the same. Okay? Now, what you need to understand about equilateral triangles is that they are also equiangular. What does that mean?
They're all the same.
What's all the same?
All the angles.
Okay? So all the angles are the same. Now, if you're someone who, let's say you can't remember that equilateral is equiangular, let me just pose something to you. Okay, this side and this side are the same, so these base angles are the same, true? And then if I turn my paper, and I cover that up, this side is the same as this side, so these two base angles are the same, are they not? And then I could do it again, like, do you see how they're all the same? Because it's an isosceles triangle, no matter which direction it sits. Okay, I don't know, well, okay, it's asking for the measure of the arcs. Remember that the arc is connected to the angle that it is across from. So what kind of angles are these? Central, inscribed, inside, outside. What kind of angles are those? They're inscribed. See, like this? Because you could go like that. Right? So, these are all inscribed angles. And we know that the inscribed angle is half of the arc. But we're not asked for the angle. We're asked for the arc. What do we know about the arc? We wrote it down yesterday. What do we know about the arc? It's 2 times the angle. So I'm just going to write this down over here. Now let's get back to the triangle. If you have 3 angles that are all the same, you do not know what they are, so you could give them an x. How many x's would you see? 3. And so 3 x's have to add up to what grand number? It's a triangle. 180. So if all 3 x's have to add up to 180 and you divide by 3, how much is 1x, one angle? 60. Okay, so if the angle is 60, how do you get the arc? So, yep, the arc is 2 times the angle, which is 2 times 60, which is how much?
120.
Yep. So 120. So this is 120. How much is this arc over here?
120.
That's 120. How much is this arc down here?
120.
Now let me ask you a question. If you add up all of your arcs, how much do you get?
360.
And what do you know about 360?
It's over here.
It's the circle. Right? 360 is a circle. Okay, and that's how you can kind of check your work there. All right. Number 5 says find the arc length of RS. And it says that the radius is 5. So R equals 5. All right, before we do anything, you can see that you have an 80 here, you have a 120 here, you have a 60 here, okay? And then we have this part here that we don't know, all right? But how much do all of those have to add up to?
360.
Okay, so how much is going to be my green angle? 360 minus all of those. What do you get for your green angle?
100.
Okay, so that's 100 degrees. Now, we're not asked for the measure of the arc. We want the arc length, so we have to look all the way back here to the very front. Do you remember when we did arc length is degrees over 360 multiplied by the circumference? Okay, and we're given a radius. So the arc length is 100 degrees over 360 times 2 pi and then 5. 5 is your radius. And then I can just put that in my calculator, right? 100 divided by 360, 2 pi 5. Oh, I put it in the wrong spot. Arrow over. 2 pi 5. I get 25 pi over 9. Okay? Now I just want to say something in case I didn't say it yesterday. If all of your answer choices are in terms of pi, do you need the decimal answer?
No.
No. If all of your answer choices are decimal answers, what do you need to pull out of your calculator? The decimal. 8.73, like whatever, whatever we're rounding to. So just be mindful of your answer choices. Okay? All right. Then these three here, 7, 10, and possibly 12. So we're going to be converting between degrees and radians. All right. If you have degrees, you're going to put it over a 1. And then you're going to multiply it by pi over 180. The answer you get will be radians. And we want pi answers only, no decimals. Okay, decimals are not radians, they're decimals. Pi answers are radians. Okay. Now your degree symbol will cancel out. You can type all that in the calculator and you'll get your radians. Now if you're given radians, I'm not going to put it over a 1 because as you can see in 10 and 12, sometimes your radians is a fraction. And we don't want to put a fraction on top of a 1. So, multiply. So to go backwards, radians, and then here we're going to have 180 over pi. That will give you your degrees. Radians is a pi answer. We have a pi in our denominator, so these pi's will actually, they'll cancel each other out. I say that. They'll simplify to one whole, and you'll be left with degrees. Okay, so let's do number 7, 40 degrees. So we're going to write 40 over 1 times pi over 180 And we're going to put that in our calculator. 40 times, and then we're going to do pi divided by 180. Now you can type it like this. 40 times pi divided by 180. You're going to get 2 pi over 9. 2 pi over 9 radians. And that's your answer. No decimal. No decimal. Not allowed. Okay? So, number 9 is just like that one. Number 11 is just like that one. You have to multiply by pi over 180. You know, like when you're driving down Sunnyside and the speed limit's 40 miles per hour? 40 miles per hour is a conversion rate. This is your conversion rate. Okay? All right, so now we're going to go to number 10. We're given 3 pi over 10 radians. Okay, so 3 pi over 10 times 180 over pi. I want degrees, so I need degrees in the numerator. You see that over here? I want degrees for my answer, so degrees are in the numerator. On this one, I wanted radians, so pi was in my numerator. So it kind of matches. All right, now to make your job easier in the calculator, you can go like this with your pencil, because these pi's will reduce to one whole. And now you're going to have 3 times 180 divided by 10. You can pop that in the calculator. 3 times 180 divided by 10. You're going to get 54. You could also do 3 divided by 10, arrow over, multiply by 180. You'll still get 54. Okay? You can type the pi's in. You'll still get 54. But you need to have a little degree symbol because you're going from radians to degrees. Okay? So now the question is, do you need to see number 12?
No.
Okay. I didn't figure you would. All right. Okay, page 4. I need you, if you haven't already, please number your questions if you haven't already, and then I want you to decide which ones you want me to do. Oh. Two. We want to do 2. We want to do 5. 7. 1.
8.
8. You want to just start there and then see if you need more? Okay. So, find the diameter of a circular swimming pool. Oh, the diameter of a circular swimming pool is 12. Draw your swimming pool. And then this will be my diameter, and then that will be 12. It wants us to find the circumference. Remember that circumference is 2 pi r or pi times diameter. I've been given the diameter. Which one of these can I use? Okay, so I've been given the diameter, so I can use pi times diameter. Well, what if you don't like that? Well, if you don't like that, you need a radius. What's your radius?
6.
Okay, so if you're going to use your radius, then you would have to use the 2 pi r. It really won't matter. You're going to get the same answer no matter what you do. Okay? So, all right, circumference is pi times diameter, so pi times 12. Your answer is just a 12 pi feet, okay? And if you did the other one, if you did 2 pi times 6, you would still get 12 pi feet. Either way, you get the same answer. Now, let's say that you are building a swimming pool and you need the materials that are going to go around the edge of your pool. Maybe you're putting some bricks down. Maybe you want landscaping around your pool. Maybe whatever the reason the materials are going to go around the pool, you wouldn't go to Home Depot and say, hey, I need 12 pi of edging, please. They won't know what you're talking about. So you would need the 12 pi to be converted to a standard answer, and that would be your 37.699. So how many feet would you tell someone at Home Depot or Lowe's? If that's your decimal? Yeah, perfect. You would tell them, hey, I need about 38 feet of that black edging for my swimming pool. Okay? Or maybe you're putting pavers down or bricks or something. Okay? So 38 feet. Okay. Now number 2 says find the perimeter and the area of a rhombus with diagonal lengths of 6 and 8. Okay, up here, I want you to write this down. Rhombus or kite. You want the area, diagonal 1 times diagonal 2 over 2. And then the perimeter, you got 4 sides. In a kite, you're not going to have all 4 sides be the same, but in a rhombus, all 4 of them would be the same. Okay, so let's draw the rhombus up here. Actually, let's draw it here. So draw what looks like to be a diamond. Draw one diagonal here and one diagonal here. Now I want you to remember the characteristics of a rhombus. In a rhombus, the diagonals bisect each other. So they cut each other in half. So if this is 6, then how much is each half?
6.
3. Half of 6 is 3. Okay, the other diagonal is 8. So what's half of 8?
4.
4. So here's a 4, and here's a 4. Okay, now we need a side length. Guys, what does this look like?
Kite.
That's a triangle. What kind of triangle would that be? You have a side of 3 and a side of 4. What kind of triangle is that?
Right triangle. Right.
It's a right triangle. So we have a 3, we have a 4. Does anybody know the third side of that right triangle without doing the math?
5.
5. It's a triple. So this is, if you don't know that, you would have to do Pythagorean theorem to get your 5. Well, what do you know about the sides of a rhombus? They're all congruent. Okay, so now, perimeter. Your perimeter is 4 times the side length. So 4 times 5 is 20 centimeters. Not squared, not cubed. Okay, that's your perimeter of your rhombus. Now, if you want to, you can do 5 plus 5 plus 5 plus 5. Or you can do 4 times 5. And then your area up here, remember our area formula is D1 times D2 divided by 2. So we're going to have a 6 times an 8 divided by 2. 6 times 8 is 48. Who do we appreciate? Miss Bailey. Okay, 48 divided by 2.
24.
24. So 24 meters squared. So now we found our perimeter and we found our area. That was a good question. I'm glad y'all asked for that one.
Yes.
Okay, let's talk about this one. We've got to find the perimeter and the area. Now this is a composite figure, and the reason why is it looks kind of like a house, and I can go like this, and now I've got a rectangle and a triangle on top. Y'all see it? Okay. So before we get into the area part, let's talk about perimeter. I'm going to go in alphabetical order from P to Q to R to S to T and back to P again. From P to Q is 4 boxes. And same thing with S to T, 4 and 4. And then from P to T is 6 boxes. Now here's the problem. I can't just count this diagonal, but what I do notice is I have a yellow triangle right here. Okay? And then on this side, I have this little blue triangle right here. And those are going to be right triangles. So, how tall is the triangle top? How tall is this right here?
3.
3.
Okay, so I'm going to put a 3 right there. It's going to be a really important number. Now, forget the yellow. Just look at the blue triangle. How wide is the blue triangle? 4. Oh, hey. We got a 3. We got a 4. How much is this?
5.
5. Look at that. You're going to learn that triple yet. Okay, now over here, the yellow one, it's 3, but then how wide is it?
2.
I'm going to put a 2. Now I'm going to have to do Pythagorean theorem for that one, aren't I? Okay, so 2 squared plus 3 squared equals c squared, because this is c. I need to know what that is. Don't forget, we can literally just put all that in our calculator and take the square root. So, when you do that, you're going to get square root of 13. Just leave it like that. Okay, so that side is square root of 13. Just let that go. So now I know all the sides and I can get the perimeter, right? Perimeter is, you got square root of 13, you have a 5, you have a 4, a 6, and another 4. And you're going to add all that up. Okay, so you're going to have square root of 13, and then you're going to add all these numbers right here. 5 plus 4 plus 6 plus 4, you're going to get 19. Yep. And that's your perimeter, and it's going to be units. And I know some of you may not, oh, I don't like that answer. Well, it's okay. You don't have to like it, but that's the answer. And don't be afraid of that answer. Now we're going to find our area. Okay, so our rectangle part. Let's just talk about our rectangle. What are the dimensions of this rectangle? Length times width. Huh?
What is this?
Okay, so we're going to have 4 times 6, which is going to be 24 units squared. And that's my rectangle piece. Now we're going to talk about that triangle piece. This is one time where you can just go, how wide is that base? I have a 2 and a 4. How wide is that?
6.
And how tall is it?
3.
Okay, so the area of my triangle is 6 times 3 divided by 2, which is 9 units squared. And that triangle, okay, I can just do base times height the way it is drawn. Okay. And then I'm going to add that up because 24 and 9, how many total units squared is that?
Wouldn't it be 43?
It would be 33. Okay. All right. Okay, so I'm gonna stop right here, and we're gonna pick this up tomorrow. Okay, and we'll see how far we get. Okay.
Does that mean tag up that?
is pack-up time.
Are we still recording?